Welcome back to the Neuroscience Meets Social and Emotional Learning podcast, episode number 123, with Dr. Charles Hillman, whose research in brain scans on students during his time at the University of Illinois from 2000 to 2016 provided enough science to spearhead Naperville's zero-hour PE program that we've been covering on the past few podcast episodes that put physical exercise and its impact on cognition in the brain on the map. It was Paul Zientarski, the former PE teacher and football coach from Naperville, who mentioned Dr. Chuck Hillman's brain scan studies in our interview number 121. And I thought these brain scans were so important that I cover a deeper dive into the results of these scans on episode number 122. My name is Andrea Samadi, and if you've been listening to our podcast for some time, you'll know that we've uncovered that if we want to improve our social and emotional skills and experience success in our work and personal lives, in school, sports, and the workplace, it all begins with an understanding of our brain. The goal of this podcast is to bring in experts who've risen to the top of their field and share their knowledge, wisdom, and tips that many of us wouldn't have access to, since this understanding of the importance of our brain and results is relatively new. So here's more about our guest today. Dr. Hillman received his doctorate from the University of Maryland in 2000 and then began his career on the faculty at the University of Illinois, where he was a professor in the Department of Kinesiology and Community Health for 16 years. He continued his career at Northeastern University in Boston, Massachusetts, where he currently holds appointments in the Department of Psychology and the Department of Physical Therapy, Movement, and Rehabilitation Sciences. He co-directs the new Center for Cognitive and Brain Health, which has the mission of understanding the role of health behaviors on brain and cognition to maximize health and well-being and promote the effective functioning of individuals across the lifespan. Dr. Hillman has published more than 265 refereed journal articles, 15 book chapters, and co-edited a text entitled Functional Neuroimaging in Exercise and Sports Sciences. When Paul Zientarski mentioned that it was Dr. Hillman who helped him to make up his mind about making changes to their PE program in Naperville after he saw the scans of students' brains after just 20 minutes of walking, I knew I had to find out if Dr. Hillman would come on the podcast. I emailed him at Northeastern University on Saturday afternoon, and he replied early Sunday morning that he was interested in helping to expand on the results he discovered through his brain scans. We had a chance to exchange some emails, pick an interview time, and that's how simple it can be when you reach out to someone who really wants to see change occur in the world. Let's hear from Dr. Hillman. Welcome, Dr. Hillman. Thank you so much for an incredible chat Sunday morning as we were picking a time to speak. I know time is always a factor when I'm reaching out for this podcast, and I want to make sure we maximize our time together so we can dive deep into the research that began when you were at the University of Illinois. And Dr. Hillman, Chuck, I listened to a podcast you did with a young man from the UK. It was Daniel Elias. And I loved his introductory question to you about what it was that began your interest early in your career to study children and the impact that exercise has in their brain. Can we start here with where it began for you?
Sure. Good morning, Andrea. Feel free to call me Chuck. Okay. So I have to think back a little bit to that podcast. I imagine I probably gave him a bit of the personal story, I guess, right? Where I had a child. My son was born AJ in 2003, and at that time I was mostly studying aging, so the effects of physical activity on the aging brain. And I was living in Champaign-Urbana, which has a pretty brutal winter, and during winter there's not a whole lot to do. And so we were at that kid pit in the mall. It's like the carpeted structure that kids play on. And I was just sitting there watching my kid run around and probably having a coffee. And I just my mind started to wander to questions about physical activity in kids, because I saw some kids running around being like little lunatics, exploring all aspects, and others just sitting very quietly and having this physical activity opportunity, but not taking full advantage of it for whatever reason. And so at that point, I went back and thought about some more and had discussions with my graduate students, and we decided to conduct our first study in physical activity and brain and cognition in kids.
That's a wonderful start. I know when we have kids, our whole world's changed as we start thinking about them and how are we going to raise these little ones, especially with the knowledge that we have. So I liked
Cool.
hearing that side of how you began.
Yeah, thank you.
Well, we know from your research that it's clear that exercise has a significant impact on student achievement. And also what we saw from Naperville, how they used your research to really create this phenomenal 0-hour PE program. And then even our conversation Sunday morning, like you and I getting out into the outdoors and knowing what that does for our mindset to set us up for the week. But what about encouraging physical activity in those students who've not caught this fitness bug, or they're preferring to do screen time versus going outside? How would you suggest helping those ones out?
Yeah, I mean, there's a lot of things to think about here as we unpack this. I mean, first, I think the vast majority of children aren't sufficiently physically active. We know from the physical activity guidelines for Americans that kids should engage in 60 minutes or more of moderate to vigorous physical activity every day of the week. And that includes, the majority of the time in aerobically based, moderate high intensity exercise, but in other times during the week that also involves bone and muscle strengthening exercises, body weight and age appropriate and things like that. And so with the majority of kids not meeting those guidelines, I think, really what we're talking about here is how do we engage the majority of children to be physically active? And that's not the easiest thing in the world, especially when many children's parents or most children's parents are also not achieving the guidelines for adults. But having said all of that, during childhood is a great time to sample different activities. And, running on a treadmill or being part of a cross-country team is not for everyone, right? I think it's important that kids find things where they can be, or find environments or activities where they can be physically active, because they gain efficacy for physical activity as children, that they can then carry with them through their adult lives. And if they don't, then they have a harder time doing so later in life. And so I guess my main point, before I unpack the second half of the question, is to say that there's lots of ways to be physically active, and it doesn't all involve running, to some finish line. In fact, my son and I hate to run, quite frankly. We both play ice hockey. I mountain bike. We both lift weights. He plays lacrosse. I mean, we do a lot of different things. He boxes, and we do all these different things, but none of it involves running. And if our only choice is running, I'm not sure either of us will last very long, because we're just not, it's just not engaging for us as an activity. And so, my short message would be to keep sampling until you find something you do like. The second part of this question about going outside, I read into that as, being out in nature. And that's a really interesting question that we don't know a lot about. We do know that nature has its own benefits. And for brain and cognition, that is cognitive resiliency, things like that. And my lab right now is actually looking into this idea of exercising in nature, or virtual nature, I should say, because we're using virtual reality environments, and comparing that with virtual city scenes and seeing if exercise has differential impact based on, on the environment. And so, these are open questions, and I think they're really interesting. And I think they're really interesting for adults. For kids, I do think we have to be cautious here and recognize that, some kids are going to want to be physically active with screen involvement. And, rather than shunning the screen, which obviously isn't my cup of tea, but I mean, rather than shun the screen, I think we might want to embrace it in an effort to get kids to be physically active and then try and move them from there.
That's so interesting, because if I've noticed at the gyms, they have changed how the equipment's gone. Now you've got these fancy hiking trails that take you in. You actually see people on the trails, and it's so different now. how everything exercise has changed over the years to incorporate the screen. I never thought about it that way.
And it's even more different in the last year with our pandemic, right? Or, I mean, the number of people who either ceased exercising altogether or are doing it differently in front of a screen. Like I gave up my gym membership because I'm not going back in the gym, right? And I've replaced it with more time hiking and biking when the weather's nice.
Right.
So.
Right. Wow. Well, I want to go a little bit into some of your studies because I've done a podcast where I looked at the studies that you did that really grabbed Paul Zientarski's attention. And but before I ask the question, I just want to make sure I have the understanding of it right, because I didn't go to school for understanding neuroscience. I've just got the grasp of it from having my own brain scanned and listening to the results of yours. So when you see the higher fit students and their brain lights up all red, is that the students, the blood flow is going to their brain, which gives them more brain power? Would you say that's accurate as to why it lit up bright red, or what's happening at the brain?
Yeah, so I guess I should say that we use a variety of different imaging tools, and some of our functional MRI data do refer to blood flow in different regions of the brain in kids. But I think the figures you're referring to actually is the neuroelectric system. So what we're looking at is electrical activity of the brain rather than blood flow. And there, the figures you're looking at is a cross-sectional comparison of high and low fit kids. And what we find is that in response to the same cognitive task, high fit kids are allocating more attentional resources. That is, they're allocating more electrical activation that is known to relate to attentional resource allocation. So they're better able to capture images in their environment and respond accordingly than their low fit peers. That was where we started. Since that time, we've used randomized controlled trials and shown that a 9-month physical activity intervention does indeed engender an upregulation of attentional control, right? Upregulation of the neuroelectric resources in the brain, underlying tasks, cognitive tasks, compared to kids who are in a weightless control. We've also used imaging tools, including MRI and fMRI, to talk about structure and function of the brain, and we can get into some of those if you want. And then we've also looked at it from the direction of single doses of exercise. So not a longitudinal intervention, but rather what do we gain from one dose of exercise? And I think those are Paul's favorite data, because he likes this idea, as do I and many others, of can we temporarily improve our ability to perform cognitively, following a dose of exercise. And we do indeed know that there are benefits to brain function, cognition, and academic performance, which I think is what Paul has been interested in, as he's done a terrific job in managing the 0 Hour P and Naperville's testing and all that sort of good stuff.
Exactly, because when I saw that, I've always known intuitively that if I have to do some difficult work at my desk for long periods of time, I have to have rigorous exercise first. I didn't know all of this before I came across Paul Zientarski in Naperville and your brain scans. I had no idea that in the workplace, even in schools and the workplace, how important it is.
Yeah, it's actually really interesting. The exercise bout doesn't even need to be vigorous, we figured out. So in kids, we use a 20-minute dose of walking at a moderate pace, 60% of their max capacity. We've also used high intensity interval training, right, which is an exhausting dose, and shown benefits as well. The brain acts differently following these types of exercise, but the cognitive benefits are the same. And so it's true. I think what's good for kids, we know is good for adults. We've run some of these studies in adults as well. And it appears if we break up our day and we, take these moments to be physically active, we do seem to benefit cognitively from that activity.
Definitely. Well, this is powerful information, especially these days when most of us are doing some work at our home. So trying to figure out, and our gyms have been closed. So trying to figure out how we can get these impacts. So when I looked at your website, I went under your research tab and I can see some of the things you're working on. Can you just share what you're working on at your Center for Cognitive and Brain Health right now?
Sure. I guess we first say that our website is under construction. So in the next
Always,
couple,
isn't it?
yeah, it's time to update it because that website is really mostly a reflection of just a couple of us. The Center for Cognitive and Brain Health at Northeastern University now has 5 faculty in it, and we're not just interested in physical activity. That's certainly my area of interest, particularly in children, and my colleague Art Kramer, his interest as well in older adults. But we have interests in early childhood experiences, both positive and negative, music, and then mental health related issues as well, with some of the other faculty in there. The 2 projects I think you're referring to, one is a longitudinal study of physical activity involvement in older adults. And so there we have the IGNITE trial. It's headed up by my colleague Kirk Erickson at University of Pittsburgh, and it's a multi-site trial between Pittsburgh, Northeastern, and University of Kansas Medical Center. And we're bringing in 639 older adults for a year-long physical activity intervention, with testing at baseline 6 months and 12 months. And it's a comprehensive battery from cellular, molecular, and genetics to multiple modes of imaging, including MRI, fMRI, and PET scans, to a huge cognitive battery. And we're trying to understand whether different doses of physical activity, so people get either 150 minutes of moderate to vigorous physical activity per week, which is the physical activity guidelines for Americans, or they're getting a larger dose, 225 minutes a week, or they get stretching and flexibility training. So it's not aerobic, it's health-based physical activity training, just not aerobic. And we're looking to see whether there's differences, at 6 months and a year following these intervention arms. And so that's that. And those are 65 to 80-year-olds. And then the kids study is more about this. It's called SNEAKY. And it's more about this acute dose idea. And that we know now through multiple published findings that single doses of exercise benefit brain and cognition, academic performance in kids. What we don't know is what the mechanism is. And so this particular study is focusing on salivary alpha amylase and cortisol, 2 stress markers that we think may underlie the benefits, maybe the mechanistic reason in which a short dose of physical activity benefits brain function and cognition in kids. Exercise is a stressor; it's a positive stressor, and so we believe that we're upregulating these neuromarkers or these biomarkers that benefit both the function of the brain and cognitive output. So.
And when you were talking about your aging study, are you doing anything to show how exercise is slowing down cognitive decline? Are you measuring maybe BDNF, anything like that?
Yeah. So, I mean, we are collecting all of those cellular molecular markers, BDNF, IGF-1. We're looking at different genetic, variables as well, telomeres, so forth. And the idea is that we'll know at the end. We're still collecting data, and so this is actually, I should step back and say, this is the largest randomized controlled trial of exercise in older adults in the history of NIH. And so, we're not able to crack into the data until we're done collecting it. Everyone's, blind and all those good things that happen with randomized controlled trials. But the idea is to look at these variables and see, what are the markers that are benefited by physical activity? Are they simply curbing cognitive aging, or are they actually ameliorating and benefiting the brain and not just, slowing down the cognitive aging process? And so these are open questions.
Got it. And it's such an interest for me, going from the child, making that child a lifelong exerciser for the benefit of the health in the future to prevent Alzheimer's and aging and everything. It's a whole big spectrum.
Yeah. I mean, I guess, if we go back to your first question, one of the main reasons I really want to study kids is because I didn't want to wait until someone was in their 60s to say, hey, exercise is good for your brain. Let's get you going to ameliorate these cognitive aging effects, or worse, dementia, right? Early onset dementia, things like that. And so I want to look and see whether we could benefit the brains early, build up a neural reserve or a cognitive reserve, and maybe we never have that sedentary adult that is suffering from age-related decline.
Well, I find this fascinating. Dr. Hillman, Chuck, at your lab, you mentioned you're using different scans. What do you think is on the horizon as brain scan technology advances? What are you going to be looking for in the next 10 years or so? What's your vision for this?
Yeah, I mean, that's a good question. This field is expanding very rapidly. I can tell you that, back in, say, 2014, we were happy to see differences in regions of brain that differed as a function of some exposure, right? Physical activity, doses of exercise, what have you. But now, that's not really where we are anymore. I mean, we're much more interested in neural networks. And so, can we predict changes in networks, regions of brain strung together that perform a like activity in response to something? Can we see differences between how these networks operate between each other as well? It's not just changes within these networks, but changes between the networks. There's all kinds of really interesting analyses that are going on that allow us to examine and understand the brain differently. And so, while I won't doubt that new measures coming along, I think really what we're going to see is a better ability to make use of the MRR environment. With more sophisticated head coils to get better resolution, greater understanding of how the brain is working together or opposite each other, different regions opposite one another. I think we're going to be able to do a better job of combining structure and function into more of a singular understanding. So, traditionally, as this developed, we would measure brain structure and see changes, either it wasn't even gray matter or white matter, it was just the volume of the brain. And now we can separate gray matter and white matter and look at differences in those structures. And then we, secondly, look over at function, or separately look at function of the brain. And now I think we can start to tie these together and get a better understanding of how whole brain is benefited by physical activity. And I think as we get better at this, our models of brain networks will expand from, say, 7 to 17 and so forth. We'll get more refined in our understanding. I don't know how long that will take, because these things, there's people who do this for a living, and they understand. I have much more of an applied focus. And then I'd be remiss if I didn't say that I think that also multimodal imaging is really where the future is. So combining, like, for instance, EEG and MRI, or combining functional MRI with, PET or MEG, or all these different imaging tools, see if we can converge on a single outcome, single finding.
And then just how do you see this information coming to the masses? So you've got these incredible scans that went in to make an impact on Naperville and really opened up the belief. So years ago, when Paul Zientarski showed this to a lot of his colleagues, they were all looking at him like they were crazy, and he's walking around trying to bring this to the masses. Do you think that it's becoming easier to translate something that is, you've studied years for, but many of us have not? How do you see this transitioning into real use for schools and the workplace that people can understand and apply?
Yeah, this is a great question, Andrea, because I think it highlights the limitations of really what we can do as scientists. I mean, just as you keep saying you're not trained in neuroscience. Well, I'm not trained in public outreach. I'm trained to design a study, analyze the data, write it up for the small number of scientists in the world who are interested in this area and go on to my next study. One of the things that I would really love to do in the future would be to expand my center, the Center for Cognitive Brain Health, to include someone who's expert in public outreach. I think that the Paul Zientarskis are really rare. I mean, here you have a guy who spent his whole life in secondary education, and he's kind of gone outside his comfort zone to understand the neuroscience and bring it back. And I think we need more people like that. And I think you're probably not going to understand every detail of every measure. I think that we can speak a common language where I can inform his outreach, and he can inform in turn, some of the challenges they face, and we can see if we can turn those into experiments, right? To try and provide more information in those areas and see whether we're barking up the right tree. But I think it's gonna require someone who's kind of in this intermediate zone, right? Or this intermediate area, and that hasn't been well defined yet.
I love that whole side of it, because it was an educator who told me to go this route in about 2014 when some of my programs won some awards in Arizona. And he said, you've got to add the brain science in here. And so I found a researcher who helped coach me. And then in the beginning, it was so challenging to, look at how memory works in the brain. But if I could have figured it out, I think anyone can. And so that's the whole idea behind the podcast, is to make this bite-sized, make it so that anybody can take this information and use it. So I really do appreciate that insight, because it can feel, even the word neuroscience, what does it exactly mean? For somebody who hasn't come from that background.
Sure. I mean, I think as time goes on, we all kind of specialize into our own areas, and we don't look up very often. And it's, I think one of the biggest changes we've seen in the last 10 years in academia and research is this notion of interdisciplinary science. And that's been great, because I haven't had to change the way I work, because I've always been sort of interdisciplinary in my questions and my approach to science. And so I think that as that expands, I think that that's going to expand into dissemination models and models that would afford people to take the science, actually go and utilize it in real life.
Love it. Love it. Well, Chuck, Dr. Hillman, I want to thank you so much for your time today. If anyone wants to learn more about you and your work, is the best way through Northeastern, through your website, your Center for Cognitive and Brain Health Lab? Is that the best place?
Yeah, as I said, the website's up and coming, but it's something we're starting to focus on now again, and so that's certainly where we post our newer papers and things like that. Certainly.
Perfect. And I've put links in the show notes for how to access you through Facebook, Twitter, and LinkedIn, if anyone wants to find you. And I just want to thank you so much for your insight, for your research, for what you've done for the world, because it really was your brain scans that impacted Naperville. And so I just want to thank you for the work you're doing behind the scenes, all that time in the labs. It's really making an impact, catching attention worldwide. And I just want to thank you for what you've done.
Thank you, Andrea. I appreciate the kind words. It was nice talking to you today.
You too. You have a wonderful day.
You too. Take care.